Here we have a problem that is not solved as straightforward as the other ones that we have had on this review. This problem requires us to use both the remainder and factor theorems to complete all of the different parts of this. So what we have is we have an equation with an extra variable. And then we have been told that this is a factor, and that when we divide that synthetically, that second part is what we will get. So, and then we have three numbers here to figure out. And once we do that, we need to factor completely. So this brings almost everything that we have done so far together. So the first thing to do would be to figure out what P is, because we can't move forward if we don't know where we're starting from. So if we were synthetically dividing, this factor would give us a C of 2. So that means by our remainder theorem that if we plug in 2, that would equal 0, because if it's a factor, our remainder is 0. And when we plug something in, it will equal the remainder. So to go from here, we need to actually plug in that 2. So we have 3x squared, and now our x is 2, plus 5, oh, that's a cube, 3x cubed, plus 5x squared. Now this is squared, and we're plugging in a 2, plus px, x is now 2, plus 8, and that's equal to 0. So we need to evaluate all these numbers and try and solve for p if we can. 2 cubed is 8, so we have 3 times 8, plus 5 times 4, plus 2p, plus 8, equals 0 still. So let's finish multiplying, then combine these numbers. So we have 24 plus 20 plus 2p plus 8 equals 0. So this is 2p plus 52 equals 0. So remember, we're solving for p because we want that original equation. So we subtract 52, we have 2p equals negative 52. Divide by 2, p is negative 26. Now that we found p, we can rewrite our original equation. So our original equation is 3x cubed plus 5x squared minus 26x plus 8. Now our goal is to factor out the x minus 2. The best way to do this, unless you have some magical factoring abilities, is to use synthetic division. So now that we have all the numbers, let's synthetically divide this. So 2 is going to be what we're dividing by. Our coefficients are 3, 5, negative 26, and 8. And then we do synthetic division. So you drop down the 3. 2 times 3 is 6. 5 plus 6, remember we're adding, is 11. 2 times 11 is 22. 26 minus 22, or negative 26 plus 22, is going to give us a negative 4. 2 times negative 4 is negative 8. 8 minus 8 is 0. So remember that last number in synthetic division is our remainder. If you did not get a remainder of 0, then you need to go back and check your work, because we knew that this was a factor, so we knew this was going to work. That means when we can write this back out, this started with x cubed. So let's undo that. Okay, our original function started with x cubed. So our quotient here is going to start with x squared. So we have 3x squared plus 11x minus 4. So here are a, b, and c. So that means that a is 3, b is 11, and c is negative 4. So we have just answered the first half of this equation. We have a, b, c, and p. Then it says, using the values found, factor the original equation completely. So we know that our original equation, 3x cubed plus, that's big plus, 5x squared minus 26x plus 8 is going to be x minus 2 as our first factor. And then what we got next was 3x squared plus 11x minus 4. So it says factor completely. So right now, we don't know if we factored completely. We know we have the first factor, but we need to see if we can factor 3x squared plus 11x minus 4 any further. Since there's a 3 in the front, I would suggest using fake factoring. If you have another method to factor this that works better for you, by all means use that. If you're going to fake factor, what you do is we're going to take this and we're going to split it up into two binomials. That's our eventual goal. With fake factoring, you take the 3. 3 will go in both places. X squared will be split up into x and x. And don't forget that we need not just factors, so multiplying to 4, but we need factors of negative 12 that combine to a positive 11. 1 and 12. If we subtract those, we will get 11. That means we need 12 to be positive and 1 to be negative. So we have a negative 1, positive 12, and then don't forget your last step in fake factoring, dividing out whatever these numbers have in common. 3 and 1 only have 1 in common. 3 and 12 have 3 in common. So we have 3x minus 1 times 3, oh, we divided that out. Dividing 3 out of both of those will give us an x plus 4. So here are 2 other factors. So our final answer comes together, completely factored, x minus 2 times 3x minus 1 times x plus 4. And now we've found all the variables. We have a, b, c, and p, and we have factored it completely.